Pandas offers some advanced and useful functions for data manipulation and analysis. These functions will help you to retrieve basic information about your data frame, find unique values, apply custom functions, and sort your data efficiently. So let's start off by importing our pandas and creating a basic data frame that we're going to be using. So let's import pandas as PD. Then let's create our data. And we're going to have a data frame of employees, their departments that they're working, and their salaries. So let's do employee as our first column. And we're going to have Alice, Bob, Charlie, David, and Eve. Our second column is going to be the department. And here we're going to have HR, IT, finance, IT again, and HR again. And then last, we're going to have salary. And we're going to have 70,000, 80,000, 5,000, 82,000, and 68,000. Okay. And if we do this, df, we create our pandas data frame. We pass in our data, and when we take a look, we have created our data frame. Now, when working with Pandas data frames, it is important for understanding the structure and content of your data frame, which is crucial for performing any analysis. So when you're going to be analyzing your data, you have to be able to know what kind of information you want to extract, how to find various specific things, and this is going to help you to answer different questions about your data and how to solve different problems, whether it's in machine learning or in business or anything else. So it's important to be able to manipulate and to extract the information that you need about your data frame. Now, starting with some of the basics when it comes to, for example, getting the summary of your data frame, the info method provides a concise summary of the data frame, including the index dtype, basically the type of values that are in the columns, the column types, the non-null values, and the memory usage. So if we do df, our data frame dot info, click play, we get exactly that, which is a complete summary of our data frame. And it tells us what columns we have, how many non-null values we have, or whether they are null values, what kind of dtype they are. Usually if it's a string, then it's considered an object, but if it's a number, then it has a specific number type, whether it's int, float, or anything like that. And of course, the memory usage, how much exactly that data frame weighs in terms of memory. If you want to find out what columns exist in your data frame, you would use the columns method. So again, our df.dataframe dot, and then we just do columns, and this would provide this list of column names that are or exist in our data frame. Similarly, you could also use the keys method to get the list of columns. So we could do, well, actually, we could comment this out and do df.keys And when we run this, we get pretty much the same thing. If you want to get the first few rows of your data frame, just to get like a quick sneak peek of what is in your data frame, you would use the head method. By default, it shows the first 5 rows, but you can specify the number of rows that you want. So again, our df data frame dot head, and when we click play, we have at this point exactly 5, so it would show all 5 rows. But if we want to specify specifically, let's say they're only the first 2 rows, then we could put in the 2 here as a parameter for head. And when we run that, we get the first 2 rows instead. And of course, this can be changed to 10, 50. This comes really in handy, especially when you have an extremely large data frame, which has maybe thousands of rows, and you don't want to print all of it, but rather, just a quick sneak peek of the first 10 rows, just to see what exactly is there. Similarly, you could use the tail method to get the last few rows of your data frame. So again, df.tail method is going to return the last 5 rows. But again, since we already have exactly 5 rows, we could do 2 again, and it will give us the last 2 rows of the data frame. If you ever need to perform operations using NumPy, you can convert the data frame to a NumPy array using the values attribute. So if we do df.values, this creates an array of basically all the data in our data frame, which is exactly a NumPy array. If you would want to get the number of elements, the total number of elements that exist in your data frame, you would use the size method. So df.size is going to return 15. And if we count here, 1, 2, 3, 3 in each row, 1, 2, 3, 4, 5. So 3 by 5, that's 15 elements total in our data frame. So our total size of this data frame is 15 elements. Alternatively, instead of the total number of elements, we could get the shape, or basically the dimensions of our data frame. So like I counted here, 3 by 5, we can check that by doing the shape method. So df.shape gives us a number of rows and the number of columns. So again, 5 rows, 3 columns. If you specifically only want to get the number of rows, then you would get the first element of the shape method. So basically you want to get the 5 here, so you use the first element here, so that returns of course 5. And if you want number of columns, then you would use the 1 index, and that will return 3. You can also check for unique values in your data frame. Analyzing unique values in your data can help identify categories, duplicates, or perform aggregations. You can use the unique method to find all unique values, for example, in a specific column. So let's say we want to find out how many unique departments there are. Let's actually first check the data frame to do a quick look, and we want to check the department column for the unique values. So to do that, we would do the data frame, then we would select the column that we want to check, which would be department, and then we will use the unique method to get the unique values. And here we have it. We have HR, IT, and finance. So it basically gets all the unique values and ignores any or all duplicates. You can also use the nUnique method, which returns the number of unique values in a column. So we just add an n here to the unique method, run that, and we get 3. So we have 3 unique or specific categories in the department column. You can also use the value counts method, which counts the frequency of each unique value in a column. So we could change this and unique to value counts. And when we run this, and we get the specific amount of counts for each unique value in the column. You can apply functions which allow you to perform complex transformations and calculations on your data. So let's say, for example, we want to calculate a 10% bonus for each employee based on their salary. To do this, let's first start off by creating a simple function which will calculate our bonus. So let's create a function called calculate bonus. And we're going to provide the salary into our function, and we're going to return a 10% of that salary. So it's going to be a 10% increase of our bonus. So we'll be returning the salary times 0.1, which is, or 0.10, which is basically 10%. Now, if we want to calculate our bonus based on the salary of each of our employees, we would do DataFrame, then select the salary column, and then we will use the apply method. And here we want to apply the specific function, which is the calculate bonus. And so what's going to happen is it's going to go through each row and apply that calculate bonus function to each specific row separately. And so when we run this, we get for each specific row calculated 10%. And we could go one step further and create a new column and add that to the data frame that we already have. So we could do df, and let's create our new column, which is going to be called bonus. And we're going to assign these bonuses to the bonus column. And then when we take a look at our data frame and run this, we've added the bonuses to the bonus column. And as we can see, it's 10% of this salary. So 70,000 is 7,000, 80,000 is 8,000, and so on and so forth. Instead of using regular functions, you could also use lambda functions instead to apply various changes. So let's create a new column here, and it's going to be called adjusted salary. So it's going to be adjusted salary. And we're going to assign the new salary based on the salary column. So salary dot apply. And here, instead of providing a specific function that we've created, we could provide a lambda function, or basically an anonymous function that doesn't really have any specific name. So we would do lambda x colon and then x times, let's say 1.05. And when we take a look at our data frame, in this case, we increased our salary by 5%. And so we didn't need any other external functions. We could have just done this using the lambda function. If you want to apply a function to every element in the data frame, you can use the applymap method. For example, if you want to convert all the strings to uppercase. So instead of creating a new column and creating those new values into the new column, then we could automatically apply whatever changes that we want directly to the column that interests us. So in this example, like I mentioned, we want to make all the string data uppercase. So here we would create a new cell and we would do df. And so we're going to apply this to the entire data frame. And we're going to do apply map. And we're going to use a lambda function here to check and to make the strings uppercase. So lambda x, which is our lambda function, then we want to apply the upper method. So we want to make the string uppercase. And now we want to check whether or not it's a string. So only if the type of that element X is equal to a string, else we just want to return it as is. So if it's going to be a number, specifically our salary, we can't use the upper method because it's not possible. We only want to focus on string types. And so when we run this, we can see that we have made all the strings uppercase. Now, one thing to remember here is that this will not stay permanent. So if we check our data frame again, they're all lowercase again. So if we want to make this permanent, we would have to assign it to the data frame again, these new changes, or create a new data frame, for example. And when we do df upper and we check the df upper data frame, then we have everything stored as uppercase. Sorting data is essential for organizing and analyzing it effectively. To sort the data frame based on the salary column in ascending order, we would use the sort values method. So let's create new code here, and we will do df dot sort values and by which column, and we will provide the salary column here. And when we click play, we have sorted all of it in ascending order from least to greatest. If we wanted to reverse the order, we would use the ascending parameter. So ascending, and then we will make this false, that we do not want it to be ascending, and then it will reverse it from highest to lowest. You can sort by multiple columns by passing a list of column names. For example, we want to be sorting by the department and then by the salary. So we would do df.sort values, and here we will provide the list of columns. So it will be department and salary. And when we run this, we first organize based on the department, and then we sort by the salary. One thing to remember here is that after sorting, the index remains attached to the original rows. So when it comes to our regular data frame, of course, that doesn't really change anything. So if we wanted to create a new data frame that was sorted, so let's say df sorted, and we run that, and then we do df sorted, we wanted to take a look, we see that the indexes are kind of unordered exactly. So after sorting them and we want to kind of reset those indexes, we would use the reset index method. So we would do dot reset index, and here we will use drop equals true, which basically means to drop this index column because we don't want to use it, or basically erase it, and then in place equals true. So basically means that do not create a completely new data frame, but instead modify it directly in the data frame, the index. And so when we do that, we run that, and let's take a look at df sorted again. And now it's nice and sorted from 0 to 4 again. Become a member at AILearningHub.io and get access to personalized mentor guidance, early access to AI resources, help with AI projects, and a great learning community.